Hello everyone, welcome to Nithin Academy and I'm Nithin. I hope you all have watched my previous video on physical properties. If you have not, please do. Besides, I do hope you all are having a wonderful time. And today, in Secondary 1 Science, I'll be moving on to the next chapter, Chemical Composition. And let's jump straight into it, okay? Okay, for the first segment of this video, I'll be going through elements. In Secondary 1 Science, this is something new to all of you because we are learning the periodic table of elements in secondary school, okay? So, periodic table of elements, okay? So this is something new that all primary 6 students will learn in secondary school. And this is the first thing that we're going to learn, elements, okay? So let's get started. Okay, elements. So what are elements? So this is our first question. What are elements? So elements are the basic building blocks of all living and non-living matter. Okay, living meaning us humans, all the living things, and non-living meaning just the things. Like it could be a computer, wood, a plastic bag, gold. Okay, all of this is made out of elements. Okay, next. Elements is basically a substance that cannot be broken down into simpler substances. Okay, so this is something important. Okay, so substances that cannot be broken down into simpler substances. And elements are also listed in the periodic table. Like I said, the periodic table of elements. Okay, next. So the symbols for the elements are unique, okay, to prevent confusion and for standardization. Okay, so for example, the chemical symbol for iron is Fe, and the chemical symbol for carbon is C, chemical symbol for oxygen is O, chemical symbol for nitrogen is N. Okay, so there's many of this, but it doesn't always have to be that if there's a certain element that their chemical symbol must start in the same letter, like oxygen, nitrogen, and carbon, all of them start at the same letter, right? Except for iron. Iron, the chemical symbol is Fe, and sodium is what? Na. Okay, so they are not always the first letter of the elements. Okay, and also something that you have to take note is that when you're writing the chemical symbols, the second letter over here is always in small letter. Okay, it's always in lower caps. Never write Fe. Okay, so this is wrong. Okay, so just take note. Okay, next. Okay, now in the same topic of elements, I'll be going through the periodic table of elements. Okay, so this is the periodic table of elements, and this piece of paper over here, the periodic table of elements, will actually be provided for you in your examinations. So it will be provided for you in the last page of the examination paper. Okay, so just take note. Next, so let's take a look at the points of the periodic table of elements. So firstly, the elements are arranged in the periodic table based on their properties, metals versus non-metals. Okay, so basically you need to know this zigzag line over here. Okay, so basically I'll go through this more in depth in the next slide, metals versus non-metals. Okay, so for now just take note of this. So metals are actually on this side, okay, of the zigzag line, while non-metals are on this side of the zigzag line, including hydrogen. Okay, so the left side is metals. Okay, so let me just write that down. Left side is metals, while the right side is non-metals. So just take note. Okay, so let's go through the next point now. So the next point. Okay, elements usually occur naturally on their own as solids. Okay, so let's just take a look at that. Elements usually occur naturally on their own as solids, liquids, or gases. Okay, so all these elements over here are actually natural things. Okay, so they are from nature, and they appear in forms as solids, liquids, or gases. Okay, so 3 forms. So let's take a look at the next point. Okay, 11 elements are gases. Okay, let's highlight the 11 elements. Okay, so first we have hydrogen, H, represented by the chemical symbol of H. Next we have helium, represented by the chemical symbol of He. Next we have neon, okay, represented by the chemical symbol of Ne. Next, oxygen, represented by the chemical symbol of O. After that we have nitrogen, represented by the chemical symbol of N. Then we have fluorine, okay, represented by the chemical symbol of F. Next, Cl, meaning chlorine. Okay, chlorine is a gas as well, so represented by the chemical symbol of Cl. After that we have argon. Okay, argon represented by the chemical symbol of Ar. Next we have Kr, the chemical symbol Kr. What is that? Is krypton. Okay, after that we have Xe, chemical symbol Xe is basically xenon. Okay, and lastly we have Rn, basically radon. So all these yellow color highlights are basically gases. Okay, so please do take note. Okay, next, 2 elements are liquids, mercury and bromine. Okay, so the liquids, let's highlight them in green color. Okay, bromine represented by Br, and mercury represented by Hg. Okay, next, all the others left are solids at room temperature. Okay, so there's no need to highlight the rest. Okay, so I hope you understood that. Okay, next, the diversity of matter is made up of 1 or more elements in the periodic table. Okay, so something that is made up, any matter in this world is made up of 1 or more elements from the periodic table. Okay, so any one of these elements. Okay, next we have metals versus non-metals. So I told you that I'll be going more in depth with this using the periodic table, right? Okay, do you still remember? I just said. So these are all metals, okay, on the left side, and these are non-metals on the right side. Okay, so here I have created a table in order for you guys to see clearly. Okay, so metals have a shiny appearance. Metals have a shiny appearance, while non-metals have a dull appearance. Okay, metals are malleable. Okay, while non-metals are brittle. Okay, malleable and brittle. So you have heard these 2 words in my previous video, physical properties. So malleable means that it can be beaten into sheets. So basically the metals can be beaten into sheets and it will be fine without breaking. Okay, so that's what it means by when metals are malleable. Okay, while brittle means easily broken. Okay, so please do take note of these two words. Okay, metals are also ductile. Okay, ductile. Ductile meaning that they can be drawn in wires. Okay, so I've also taught this in the previous video, physical properties, so I hope you understood this. So please do go check out my previous video on physical properties for you to understand this chapter more. Okay, metals also have high melting and boiling points, while non-metals don't. They have low melting and low boiling points. Metals are also good conductors of heat and electricity, while non-metals are poor conductors of heat and electricity. Okay? So, I hope you understood this metals versus non-metals. Okay? So let's move on. Okay, for the second segment of this video, I'll be moving on to compounds. So let's take a look at what compounds are. Okay? So what are compounds? Okay, a compound is a substance that is made up of two or more different elements chemically combined together. Okay, chemically combined meaning chemically bonded together. Okay, so made up of two or more different elements chemically combined together. Okay, so this is what a compound means. Okay, next let's take a look at the properties of compounds. Okay, so let's just take note that they are made up of two or more elements. Okay, is that it? No, two or more different. Okay, different is a key word. Elements and chemically bonded. Okay, together. Okay, so this is also a keyword. So this means that this compound can only be separated into two elements by chemical separation techniques. Okay, so separation techniques, I've introduced this word to you. Okay, separation techniques I'll be going through in the next chapter. Okay, so the next chapter after this is basically separation techniques. Okay, so I'll go more in depth about separation techniques in the next chapter. Okay, so I hope you understood that. So let's take a look at the properties of compounds now. Okay, properties of compounds. Okay, so for the first property of compounds is that compounds do not have the same properties as their constituent elements. So meaning that they do not have the same properties as the elements that made the compounds. Okay, so they do not have the same properties as their constituent elements. Okay, next, the second property is that when a compound is formed, a chemical reaction occurs. So this is really important. Actually, all of this is really important. Okay, so when a compound is formed, actually a chemical reaction needs to occur in order for a compound to be formed. Okay, next, the third property of compounds. So the elements that make up a compound are always combined in a fixed proportion by mass. Okay, are always combined in a fixed proportion by mass. Okay, so this is really important. They always need to be combined in a fixed proportion by mass, or else it will go wrong. Okay, you can't make the compound that you need. Okay, next, a compound cannot be separated into its constituent elements easily. Okay, like I said, we need to use chemical means in order to separate a compound into its constituent elements. Okay, so what is this chemical means? Okay, so next. Okay, so for next segment over here, segment number 3, I'll be going through mixtures, and I hope you understood about the previous segment, compounds. Okay, so let's take a look at mixtures now. Okay, mixtures. What are mixtures? A mixture is made up of two or more elements and or compounds that are not chemically bonded. Okay, so let me highlight this part. It's made up of two or more elements and or compounds that are not chemically bonded. Okay, so a mixture is made up of elements only, compounds only, or elements and compounds only. Okay, meaning that they do not, so it's basically a mixture of elements, just only elements or only compounds, or it could be a mixture of both elements and compounds. Okay, so not chemically bonded together, meaning that they can be separated using, so it means that they can be separated using physical methods. Okay, unlike compounds which can be separated using chemical means, because it's actually harder. So using physical methods. Okay, so let's take a look at the properties of mixtures right now. Okay, for you to understand more about mixtures. Okay, a mixture has the same characteristics as its constituents. Okay, so unlike compounds which do not have the same characteristics as its constituents, mixtures do. Okay, next, the constituents of mixtures, okay, do not have a fixed proportion. So it can be a lot of elements and very less compounds, or a lot of compounds and very less elements. So there is no fixed proportion. Okay, next, when a mixture is formed, no chemical reaction occurs, unlike the compounds. Okay, next, that's why a mixture can be easily separated by physical methods, like I said over here. Okay, like I said. Okay, so I hope you understood that. Now let's move on. So in mixtures, there are actually two types of mixtures. Okay, so let's go through these two types of mixtures in a deeper level. Okay, the two types of mixtures. Okay, there's two types of mixtures, so let's take a look at it. So first of all, being solutions, and secondly, suspensions. Okay, so let's take a look at solutions first. Okay, a solution is basically a mixture of soluble substances. Okay, before that, there's a few vocabulary that we need to know, meaning solution, solute, and solvent. So these are the vocabulary we need to learn first. Okay, so solution, what is a solution? A solution is basically a mixture, okay, a mixture, like a mixture over here, in which one substance completely dissolves in another substance. Okay, for example, salt solution is when salt completely dissolves in water. Okay, next, let's take a look at what a solute means. A solute is basically the substance that dissolves in the solvent, meaning like the salt that dissolves in the water. So in a solvent, meaning, so now you already know what solvent means, right? A substance that in which the solute dissolves in. So basically it's water. Okay, so let's just take this simple experiment. So basically salt solution. Okay, so imagine this is salt solution. Okay, so we are like sprinkling some salt into it. So this is basically the solute, and this is basically the solvent, and the end result will be solution. Okay, so this will be the solution. So I hope you understood that. Now let's take a look at the others. Okay, so now let's take a look at the solution points. Okay, first point. In terms of particles, a solution is a mixture in which the constituent particles are mixed evenly. Okay, it's a mixture in which the constituent particles are mixed evenly. Okay, so it does not so solutions and suspensions, right? So that means that the salt particles will not suspend in the water. It will mix evenly and we can't see the salt particles with our naked eye. Okay, so just like that, so they are mixed evenly throughout. And another thing, that means that the solute particles separate and mix evenly with the solvent particles. They spread evenly throughout the whole solution. Okay, so they spread evenly throughout the whole solution. Next, a solute particles are too small and cannot be seen and can pass through the filter paper easily. Okay, so if you want to try to separate the salt particles from the water particles, filtration is not the best physical method, because the salt particles are smaller than the filter paper holes, the filter paper holes, so meaning that the particles will actually just pass through the paper and not be filtered. Okay, so that's why this is the wrong setup. We won't get the what we wanted to obtain, basically the salt particles. Okay, next. Okay, so solutions can be described as dilute or concentrated. So what does dilute and concentrated mean? Okay, so for the same volume of solvent, okay, so let's imagine, so that's a volume of solvent over here, so let's just imagine. Okay, a dilute solution contains less solute, meaning there's less salt. Okay, while a concentrated solution contains more solute, meaning it contains more salt. So this solution over here is more concentrated, while this solution over here is dilute. Okay, so I hope you understood that. Okay, so now let's move on. Okay, now let's go through suspensions. Okay, so suspension is basically a mixture of insoluble substances. Okay, a suspension is a mixture that contains insoluble substances in a liquid or gas. So insoluble substances meaning like sand and water. Okay, next, the solid particles in a suspension do not dissolve, unlike the salt. Okay, when a suspension is left to stand, the solid particles will settle to the bottom of the mixture. Okay, so for this case, let's say sand. Okay, so when a suspension is left to stand, the sand particles will settle down to the bottom of the mixture, because the sand particles are actually insoluble substances, so that's why they do not dissolve in water. Okay, so that is why they will settle down to the bottom of the mixture and they will not mix evenly with the solution with the solvent. Okay, solvent meaning water. Okay, when a suspension is filtered, the solid particles will form residue. So residue is basically the sand that is left on the filter paper, and the mixture that is being filtered, and the what you obtained after you filter the suspension is basically the water, right? The pure water. So that water is basically the filtrate. Okay, so let's take a look at a filtration setup that I've drawn over here. So this is a filtration setup. Okay, so this part over here is the residue, okay, and this over here is the filtrate. And I hope you can recognize these two lab apparatus. So this being the filter funnel, so this line over here, filter funnel. So let me just write that down, filter funnel. So this is the filter paper, and this is the beaker. Okay, so residue. So residue is basically the insoluble substance in a suspension too big to pass through the filter paper, so they are retained. Okay, and filtrate is basically the liquid part of the suspension, and they may contain solute dissolved in solvent. Okay, so if we have this setup over here, basically that's a beaker. Wait, sorry, let me draw it properly. So imagine if there's a beaker over here, and this solution, there is salt and sand. Okay, so this over here is basically the sand, and the salt particles are just around. Okay, so after we filter it, what are we supposed to do? We are going to do something using the evaporation. Okay, so this is slightly into the separation technique. So in the first video of our scientific endeavor, I've shared slightly on this. So basically where we have an evaporating dish. Okay, wait, sorry, let me draw that properly. Basically where we have an evaporating dish, a wire gauze, okay, and a tripod stand. Okay, and over here we have a Bunsen burner. Okay, so heat. So this is the setup, and we put the solution, and after all the water has evaporated, we get salt at the bottom. Okay, so this is the setup that I've taught you in my first video. So it's just I only explained slightly on it. So in the next video I'll explain more of these physical methods more deeply. Okay, so with that, let's move on. Okay, next let's take a look at solutions versus suspensions in the form of a table for you to see more clearly. Okay, solutions versus suspensions. Okay, this is in a table format because examiners ask this very common exam question. What like give two differences between solutions and suspensions, or give three differences between solutions or suspensions, or state all the differences between solutions and suspensions. So there's many varieties that they can ask this question in. Okay, so let's take a look at the differences between the solutions and suspensions. Okay, so firstly, solutions are homogeneous, meaning the color, density, physical and chemical properties are same throughout the solution. Okay, so they are same throughout the solution, while suspensions over here are heterogeneous. Okay, meaning that their color, density, physical and chemical properties are totally different throughout the whole solution. Okay, solutions, when it's left to stand on its own, the solute does not separate from the solvent. Okay, while in suspensions, when it's left to stand on its own, the insoluble solids settle to the bottom of the container. Okay, when solutions are filtered, no filter particles will remain on the filter paper because the particle size is actually too small, and it passes through the filter paper really easily. While for suspensions, the insoluble solids are obtained on the filter paper because they actually are too big to fit through the filter paper. Okay, their particle size is too big, larger than the filter paper's pores, and thus it does not pass through, and only the solvent is obtained. Okay, So in solutions, light can pass through fully, while in suspensions, light cannot pass through fully. Okay? So this is just a brief summary of what we have already learned in solutions and suspensions from the past 2 slides. Okay? So I hope you understood this. Now let's move on. Okay? Next, solubility. Segment number 6. Okay? Let's take a look at solubility. Okay, so what is solubility? Solubility refers to how well a solute dissolves in a fixed volume of a particular solvent. Okay, how well a solute dissolves in a fixed volume of a particular solvent. Okay, so the key word is how well. Okay, so first, now that we know the definition to solubility, let's take a look at the factors affecting solubility. So this is something that they will test you in exams. The factors affecting solubility. Okay, so let's take a look at the first factor. The first factor is basically the nature of the solute. Solute meaning what you're going to dissolve into the solvent. Okay, so different solutes have different solubilities in the same solvent. Even for two different solutes that can dissolve, their solubility in different solvents is different. Okay, so different solutes have different solubilities in the same solvent. Okay, even for two different solutes that can dissolve, their solubility in different solvents is different. Okay, so I hope you got that. Nature of the solvent. Next, the solubility of a substance depends on what the solvent is. Okay, the same solute has different solubilities when it's placed in different solvent. Okay, meaning that if we have a solute called salt, right, and we place salt in water, it has a different solubility than when we place salt in alcohol. Okay, next, for solutes which are soluble in two different solvents, the solubilities are also different, meaning that for solute that is soluble in two different solvents, right, each of the solubilities are actually different. Okay, next factor we need to take note is the temperature. Solubility increases with increase in temperature. The hotter the mixture, the greater the amount of solute that can dissolve. Okay, so the hotter the mixture, the greater the amount the solute that can dissolve. Okay, so in examinations, right, they will ask you with like some experimental setup, they will ask you this question. So how can we increase the solubility of this substance in order for it to dissolve faster in the solvent? Okay, so basically what we can tell, right, is to tell them that okay, we can increase the temperature of the solute so that we can increase the temperature of the solvent, okay, or basically the whole mixture, so that there's a greater amount of solute that can dissolve in the mixture faster as well. Okay, so this is something that you have to take note. Okay, so next, okay, so just like solubility, let's go through the rate of dissolving. Okay, the rate of dissolving. The rate of dissolving refers to how fast a solute dissolves in a solvent. Okay, so dissolving refers to how fast a solute dissolves in a solvent. We can measure the rate of dissolving of a substance by measuring the amount of substance dissolved per unit time. Okay, next, so let's just take a look at the factors affecting the rate of dissolving. One being temperature. Okay, the higher the temperature of the solvent, the faster we can expect the solute to dissolve. Okay, so this is something that is commonly tested. Okay, rate of dissolving. So they have different scenarios when they're testing this rate of dissolving. Okay, so they will tell you like something like, okay, so there's this sugar particle and this other sugar particle. So and this beaker over here has a temperature of 25 degrees and the other beaker has a temperature of 30 degrees. So which beaker, when we put the sugar in, will dissolve faster? So you have to like say it's the one which is 30 degrees Celsius, because the higher the temperature of the solvent, the faster we can expect the solute to dissolve. So that's how you're supposed to like explain it. Okay, so the next factor, size of the solute particles. So this is something that has big effect in the rate of dissolving. So let's take the same example. Okay, so let me draw it out. Okay, 25 degrees Celsius, and this one 30 degrees Celsius. So here we have big sugar particles, okay, and here we have small sugar particles. Okay, so the big ones will take a longer time to dissolve. Okay, or let's take out the temperature. Let's just say that both of them are 30 degrees, then only it will be fair. Okay, so the bigger particles, right, the bigger sugar particles will actually take a longer time to dissolve because they have a larger exposed surface area. So they have a smaller exposed surface area, so it takes a longer time for it to dissolve, whereas the smaller sugar particles have a larger surface area, so that it dissolves faster. Okay, so smaller the sugar particles, the solute particles, the faster we can expect the solute to dissolve. Small particles actually have a larger surface area that comes into contact with the solvent. Okay, so this is basically what I've explained. Okay, next, rate of stirring. The faster the rate at which we stir the mixture, the faster we can expect the solute to dissolve. Okay, so these are the three factors affecting the rate of dissolving. Okay, so I hope you understood that. Now let's move on. Okay, so for segment number 8 of this video, how can we distinguish between elements, compounds, and mixtures? Okay, so how can we distinguish between elements, compounds, and mixtures? So there's a table over here, elements, compounds, mixtures. So the composition of elements, compounds, and mixtures. So elements are made up of only one element. Okay, compounds, 2 or more elements, mixtures, 2 or more different elements and or compounds. The properties of elements, none. Compounds, different from the constituents, while for mixtures, similar to constituents. The proportion of constituents for elements, none, because there's only one element. And compounds is fixed, and mixtures are not fixed for the proportion of constituents. Elements, the formation, they are formed mostly naturally, and for compounds they are formed using by chemical reaction, and for mixtures they are formed using physical change. Okay, next, for element separation of constituents, you can't separate because there's only one element over here. Okay, so there's only one element, so you can't separate. While for compounds, we use chemical means in order to separate. So chemical means such as electrolysis, and for mixtures, physical means, so the separation techniques that I'll go through in the next video. Okay, chapter 4. So physical means. So with that, this is how you distinguish between elements, compounds, and mixtures. Okay, so this is it. So with that, I've come to the end of this video. Okay, thanks for watching, everyone. I hope you have enjoyed this video and understood more about Secondary 1 Science, the third topic of chemical composition. And I hope this really helps you. If you're not subscribed to Nithin Academy, please do subscribe and be a part of our family. I'll see you again in my next video. Bye!